Electrochemical machining, ECM, definition, parts, working, materials, applications, principles, benefits and limitations. Electrochemical machining, ECM, is a process of removing metal with the assistance of the electrolysis process. The electrochemical process is otherwise called the reverse of the electroplating process, while in electrochemical machining the metal is eliminated from the workpiece. This process is utilized for the large-scale production of machined parts. In the electrochemical process, how the material is taken out from the workpiece is quite unique. The electrochemical reaction happens at the anode, workpiece, and the cathode, device, as well as the encompassing electrolyte fluid. As the electrical current is applied across the anode, ions move between the tool and the workpiece. In electrochemical machining, positive ions or particles move toward the tool, and negative ions or particles move toward the workpiece. This is something contrary to electroplating. As electrons cross the gap between the workpiece and the tool, metal particles go over from the workpiece. These ions combine with hydroxyl ions to form metal hydroxides, which are carried by the electrolyte solution. The outcome is a smoothly completed workpiece with the ideal material eliminated to create the necessary shape. Working of electrochemical machining. The working of electrochemical machining begins with the advancement of the tool toward the workpiece. The tool and the workpiece are kept in a suitable electrolyte with a tiny gap between them. When the potential difference is applied, DC, the workpiece starts acting as an anode and the tool begins acting as a cathode. At the point when the state of electrolysis is fulfilled, the removal of metal from the workpiece begins. The removal happens as per the shape of the tool. Material is removed from the workpiece and gets settled down as a slug, which is because of the flow of electrolytes. The electrolyte then, at that point, goes through a filtration process. In the filtration process, the electrolyte is passed through a centrifuge where the slug is eliminated. Then, at that point, it passes through a filter where other remaining impurities are taken out. Assuming that there's an increase in the pressure of the electrolyte, the pressure valve deviates the progression of the electrolyte directly to the tank. Materials and designs used in the ECM process. A. Materials. Any electrically conductive materials, yet the most ideal for high strength, hard, greater than 400 VPM, or challenging to machine materials. Component is stress-free with no distortion, however, has a lower weariness life that produced by stress-inducing cycles like ECM. Poor operating circumstances can prompt hydrogen pickup in steels. B. Design. Holes down to 3 mm diameter. For more small holes, ECM and stem can be utilized. Deep holes have a taper of 0.001 mm. 1. Overcut is 0.131 mm, however, can be nearly disposed of with a special tool design. Internal radii 0.2 mm, outer radii 0.05 mm. In this machining system, the tool is connected or associated with the negative terminal of the battery and workpiece is associated or connected with the positive terminal of the battery. Different construction parts of the electrochemical machining setup. 1. Power supply. 2. Electrolyte. An electrolyte is a salt solution wherein the workpiece and tool are kept during the process of machining. It likewise helps in the removal of waste products from internal gaps and furthermore acts as a coolant by forestalling overheating of the tool in the workpiece. 3. Workpiece. 4. Tool. 5. Tank. 6. Mechanical system. 7. Flow control valve. 8. Pressure relief valve. 9. Pressure gauge. 10. Pump. The pump helps in circulating the electrolyte. 11. Reservoir tank. The tank that stores unadulterated electrolytes is known as the reservoir tank. 12. Filter and centrifuge. A filter is utilized to filter the electrolyte arriving at the reservoir tank. The role of a centrifuge is to separate the sludge from the electrolyte. 13. Sludge container. A sludge container is utilized to store the sludge which is separated from the electrolyte. Applications of electrochemical machining. Electrochemical machining is utilized for die sinking and hole molding activity. Grinding by consolidating with the grinding process to eliminate material. The process is additionally referred to as electrochemical grinding. Cutting cavities, penetrating further and, surprisingly, irregularly shaped holes in complex designs like jet engine turbine sharp edges. Benefits of the ECM process. Electrolysis delivers no fumes or vapor that are perilous to people or creatures. ECM increases production rates and longer device life. ECM process is quick and requires low energy consumption. Electrochemical machining produces exceptionally top-notch parts. It produces clean parts with no welding to make them fit together. It can make exact cuts in thin metal sheets. Limitations of the ECM process. Electrochemical machining is a high-cost installation. The process additionally requires a lot of power, which makes it more costly than different processes that use molten metal. The time has come consuming since the process should be done on various occasions to accomplish desired results. When compared with different methods, ENC offers poor surface finish and uniformity due to its inclination of utilizing solvents rather than metals. Thanks for watching.